In the world of AI, what feels like science fiction one month is pretty much a standard feature the next. The pace is it's relentless. But even with all of today's powerful models, there's been this fundamental limitation that's been holding them back. So today, we're going to look at the research that's smashing through that barrier, exploring AI models that can actually teach themselves.
Okay, let's just dive right into a question I bet you felt yourself. You use a state-of-the-art AI and it's absolutely amazing. But you come back in a few months and it feels kind of stuck, right? It hasn't learned from any of its millions of new interactions. So why is that? Well, it's because most AI models are fundamentally static. Think of them like a photograph of knowledge, taken at one specific moment in time.
So in this explainer, we're going to break down this exact challenge. We'll kick things off with the AI's core learning problem. Then we'll introduce this pretty radical new idea of models that teach themselves. We'll peek under the hood to see how self-adaptation actually works, draw a really clear line between old and new AI, and finally, we'll explore the massive impact of all this new autonomy.
All right, first up, the problem. For pretty much any organization trying to use AI at scale, a major bottleneck has popped up. It's the challenge of keeping these models up to date, relevant, and secure in a world that, is constantly changing.
This slide really gets to the heart of it all, pinpointing three huge headaches. The traditional process, where a model gets its general education through pre-training and then needs specialized job training through retraining, is just incredibly slow. It's also wildly expensive. It costs a fortune in computing power. And critically for businesses, this specialized training often means moving sensitive, private data, which creates this huge security and compliance nightmare. So the crucial point to really get is this. Traditional large language models are super powerful, but they are frozen. Once they're trained, they don't learn from new conversations or correct their own mistakes on the fly. They're just snapshots, and those snapshots get old fast.
And that brings us to the solution. And this represents a true paradigm shift in how we think about the life cycle of an AI. We're moving from fine-tuning to self-tuning.
So this is the key definition right here. Self-adapting language models are AI systems that can learn from their own performance. They look at their own outputs, figure out where they went wrong, and then update themselves to get better next time, all without a human needing to step in and manage some massive retraining process.
So how in the world does an AI actually teach itself? Well, some recent papers from researchers at places like MIT and Google DeepMind highlight two really fascinating approaches for getting inside this whole self-tuning mind.
The first method is a framework called SEAL. The best way to think about it is like a really smart student studying for a test. First, it generates practice problems based on what it thinks are its weakest subjects. Then, it applies what it learned from those problems to update its own knowledge. After that, it evaluates its performance, kind of like taking a practice test, and finally, it just repeats the whole cycle, over and over, continuously getting smarter. It's a closed loop of self-improvement.
Now, the second approach, called SCORE, uses this really clever twist on a technique called reinforcement learning. So imagine you're teaching a robot to solve a maze. Normally, it would only get a treat for reaching the exit, right? But with SCORE, it gets a small treat every single time it realizes it's hit a dead end and turns around. It's rewarding the process of learning from mistakes, not just the final success. This actually incentivizes the model to master the skill of self-correction itself.
The core idea here is really powerful. Just like the quote from the research paper says, the model is learning from its own unique patterns of mistakes. It's not studying from some generic textbook. It's creating a personalized curriculum based on its own errors, which, as you can imagine, is a much more efficient way to improve.
So what does all this mean in practice? Well, it creates a really clear distinction between the old way of doing things and this new self-adapting paradigm.
This table really just lays it all out. The learning process shifts from being static and offline to continuous and in real time. The update cycle goes from slow and expensive to fast and efficient. Instead of needing these massive external data sets, the new models generate their own. And, most importantly, the autonomy shifts from needing constant human supervision to being truly autonomous.
So, look, this isn't just some cool technical achievement. This level of autonomy has some profound implications for how AI is actually going to be used in the real world. This is why it changes everything.
For businesses, the advantages are huge. First, you get continuous learning. So in fields like law or medicine, where information changes daily, your AI can now keep up without constant manual updates. Second, it's compliance-friendly. The model can update itself locally without shipping sensitive customer data off to a third party. And finally, it's feedback-driven. The AI gets better based on its actual success at real-world tasks, not just some abstract scores.
And we actually have the data to back this up. The SCORE method improved a base Gemini model's ability to self-correct on complex math problems by an absolute 15.6%. Just let that number sink in for a second. That is not a small tweak. That's a massive jump in capability. It turns a model that often made things worse when trying to self-correct into one that consistently improves.
And here's what that actually means for final answers. So look at that bar on the left. The base model only got the right answer about 41% of the time after trying to correct itself. But now look at the S-score model on the right. Just by learning how to learn, its accuracy jumped to over 64%. That is a dramatic, tangible improvement.
So let's bring it all together. The ability for an AI to teach itself autonomously, continuously, and securely, it isn't just another feature. It's a foundational shift that could very well define the entire next generation of AI.
And that leaves us with a pretty fascinating final thought, doesn't it? We've always seen ourselves as the teachers and AI as the student. But if AI can start to teach itself with this level of effectiveness, well, what's left for us to teach it? What does our role even become in a world of truly autonomous learners?